a quick introduction then. So welcome everyone. This session is about AI-powered validation for PLC, HMI, and SCADA systems using XLM's proprietary autonomous testing framework. Our speakers are Shyam, Patadia, and Nagesh Nama. Shyam is our senior AI automation engineer at XLM, and Nagesh is our fearless CEO and founder of XLM. In this session, we will also highlight some of the quantifiable benefits from this autonomous testing framework. We look at reduction of test execution time from an hour to 3 minutes. We look at protocol compilation accelerated from a day to a minute. We look at how we eliminate human error in the testing procedures. And we'll also look at comprehensive data-driven validation coverage. We'll keep the last 5 minutes of this session for Q&A, so feel free to post your questions on the Q&A tab of your Zoom chat. So over to you, Nagesh and Shyam.
Anand, thank you. Thank you, everybody in the audience. Appreciate your time. So I have a short presentation, and then you can watch the fireworks that Shyam is going to show you. Next slide, Shyam. Thank you. So my life, my professional life in computer validation started way back, 1992 to be exact. So I know a little bit about testing PLC, SCADA, HMI, MES, ERP, you can name it. Probably I would have done it one time or the other. So I know this field because I started as a PLC programmer, PLC tester a long time ago. And I built some large systems in the 90s. After that, it's running the company. So I don't really program that much anymore. So I would like to talk a little bit about status quo, then get into our framework, what we call continuous validation, which can be applied to pretty much any software platform, cloud, non-cloud. We can apply this particular use case about how to apply continuous validation to SCADA, what are its key features, the architecture, and why even you should bother using continuous validation. And we'll make a case for it. We'll have a live demo. Then you can ask us any questions. I'll be thrilled to answer your questions. Shyam? So this is the problem statement. So what we have to do is a typical legacy manual process-driven SCADA validation. You all know this, but I still would like you to walk through this because you'll see the pain in going from step 1 to step 9. Somebody has to understand the SCADA to ensure the functionality is tested, validated, draft and approve, get the approval of the test cases. Then manual execution has to happen, and the executed protocol has to be compiled. Discrepancies have to be written. Then maybe retesting has to be done. Then results have to be again compiled, finalized, a package has to be prepared, and you put it into a basket which you'll never touch. You'll never see it again. That protocol execute will go into some kind of a file folder, nowadays maybe a digital folder. You'll never see it again. Imagine if you have to do the regression testing, you'll do the same thing again and again. New validation, you'll do that again and again. So at best, this is inefficient. It is, considering today's technology, this is super inefficient. So let's go to the next slide, Shyam. So that's why we bring in continuous SCADA validation, our continuous validation platform for SCADA validation. So what we want to do, we want to make sure that test cases can be created fast and automated. So what we call lights out. First you design your framework, you push the button, you should execute one time, 1,000 times. It could be data-driven, maybe the same test cases with 1,000 data sets. We can execute that. All your boundary conditions, everything can be taken care of, for example. And each time within minutes, it gives you a report. And no human is touching it. And we not only meet, we exceed GxP compliance. I think manual testing is, depending on who executes it, has got a lot of holes. People want to bend the rules, you can definitely bend the rules. With ours, it's rather difficult because it is executed by a machine, and it's validated, and it is automatically generated without any human touching it. Efficiency, you can't even compare. Minimum 10x, maybe more in terms of efficiency. So that's what you will see. So speed and efficiency is spectacular. Regression testing, we can do 100% because it's easy. Once we design it, it should go through. It can be challenging for somebody who's not used to test automation. We are going to make it very easy with our AI-based test automation. You will see that today as well. And compliance, no questions asked. Everything is audit trailed. We not only give you the audit trail of the test sequence where the bot is actually executing and capturing all the test steps, and also all the screenshots, reports, API calls, everything it can document it. But also we'll give the audit trail of the pipeline. So you know that if the pipeline is set up, if a production pipeline has 10 steps, every step happened, detailed logs, and more than you can ever read. Those logs are given into a nice report. Also, we'll have raw logs. We also have a compilation of that in a report format, so that you have a high level report of those logs as well. Scalability, we can run this any number of times, any number of pipelines. Parallel testing, we can do that. So in none of these fronts, the manual testing can't even come close. I don't know why companies are stuck with manual testing. For some reason they're stuck. You can't even come close to what we are. And regulatory compliance is just an excuse. We comply with our platform compliance with regulations better than manual testing. So there's no question about that. Shyam, can you just explain your architecture of the CIV? Go ahead.
Sure. So this is the CIV architecture for our AI-based automation that we have developed. So again, the user will have the initial control where the user will go to the browser, record the SCADA validation test once. Again, our web actions file will be generated with our agent, and then the user will again come to the Jira platform, input that particular file. It will go to our XLM API. Our agent will parse each and every instruction present in the file and execute them, compile it into a very clean test protocol execution report, and again send it back to the Jira ticket. All of that automated end to end, and with the video recording of the execution as well, and with all the audit logs as well. So again, Jira test automation ticket becomes your source of the truth for any validations that you want to do, and each and every audit trail will be attached to the Jira ticket. So all of the execution will be taken care of by the agent that we have developed. So end-to-end lights out. We can do regression testing when where you compare to manual testing. You cannot do run a test 100 times within, like, let's say in the span of hour. But with our solution, you can do that as many times you want and generate the report. So that is the architecture of test automation piece that we have developed on top of AI. Should I go ahead with the demo?
Just go ahead, please do the demo. Yeah.
Yep. So the demo is going to be in two parts. First is we are going to see how our proprietary framework is going to run the test and actually show you the pipelines as well, what we are talking about. So let me just for now, trigger the release, and then let me go ahead and explain it. But before that, I'll just create a release for now, and then take you through what is actually the architecture, where first we need to design a pre-approved test protocol execution report, which is basically a quasi-English file, which we call feature file, where the whole flow of the test is described in a very English-looking language, which is known as Gherkin syntax. Right. So here you can see that we navigate to the application, we see the date tank, save the value of the date tank, then we verify and enter a couple of information that we want for pump 1, pump 2, everything is in English language, and we our framework will automate this whole test end to end and give you the PDF. Right. How it will do it? Let's see with our agents. So I'll just open this particular part where I have said that here our agent is listening for the jobs, and as soon as we have created the release, I have to just deploy it once. Let me deploy it. Okay. Now our agent will start listening to it.
Shyam, just zoom in a little bit so the letters are very small.
Now is it
If you
okay?
can do, yeah, still small, but we can manage. Yeah, we're good. We're good, Shyam.
This is good.
Yep. So you can see here that the agent has started running the job that I just triggered on our Azure platform. So here you can see we are basically setting up the VM, and VM will take care of the execution. So we just click a button, our code is pushed to the DevOps platform using the Git that is used for version control of the code bases, and we'll fetch that particular code uh, via this all of these tabs that you are seeing on the screen, and then we'll execute the test. So on this particular virtual machine, you will be able to see the actual browser pop up and see the execution going on. Let me just zoom out for a moment so that we can see the browser come up. Is my screen visible? Oh.
Your screen is visible. It says virtual desktop US.
Okay. Okay. Let it run. For in the meantime, I'll just show you what logs we are talking about, right? So you can see for each and every stage that is run here, right? Very detailed logs are captured here with the timestamps. For each and every job, right? So here all the information is captured, what kind of agent it is, what windows it is, where the code is stored, what is the version of the agent. All of these is being stored inside the pipelines. And uh, at the end of the execution, we will generate the report of all of these logs as well inside a single TPE. So you'll get two reports. One is the test protocol execution report of the actual test case and the audit logs of this pipeline execution, right? So end-to-end compliance is being taken care of, while let me just zoom up. Yeah. So here it is still running the job. Let it run the job. And if you can see here that, the automation is currently running. So this is whatever you are seeing on my screen right now. This browser just came up and it is trying to execute the test case. And if we want to see what kind of step it executes, we can directly go here and see, what it is trying to execute. Like it has navigated to that particular application, which we can clearly see inside this particular desktop. Right. Let me zoom out for a moment. You might be able to see it. Okay. Yep. So now we are seeing it at full resolution. So now it is trying to execute the steps that we were mentioning in the
Basically anything a human does, we can only do it faster, right? There's no limitation, correct?
there's no limitation. Yes, we can control basically whatever you see inside the browser. So it is
and
not
we can
limited.
read. We can read, correct? We can read. We can read the colors, the numbers, everything.
Everything. Yes. Which I will showcase in the second part of the demo, where we'll capture the values from the screen of HMI, and
When it's running, right,
validate.
Shyam, can you just show a TP? That way we'll save some time.
Yes,
Yeah.
yes. I'll just open the TP. So let me open the. Okay. So whatever the execution is right now going on, after that, you will be able to see again this particular TP in the form of evidence, we can say. And I just opened the bookmarks as well. So here you'll be able to see the environmental details, the links, the version of the Chrome, Windows, execution duration, everything, test execution, environmental details, then execution summary we will have, then the name of the test case, the objective, the acceptance criteria, same format. We'll have the test execution details table where we'll have
Shyam, 1 minute. Right now, with our LLM capability, we can generate. Go back to the previous page, please. All here, the test case title, the status, obviously we know it's passed or not, but test case results, the English there, even that is automatically generated, correct?
Correct. Correct. Yes. All of these is automatically generated, so nothing is manually typed in.
I don't have to prepare and tell what to put here and all that. I don't want to do that, correct?
We just have to give the web action file. That's all
That's
that is
it.
generated. Nothing else. at the end of that, you will get the TP in the same format and the video recording, two of the things, by just providing a single web action file. So yeah, so here all of these, you can see all the things with the detail. Now here, everything is captured with timestamp, and we are actually asserting the values. Now let me just move to another PDF where I'll show you what other things we can do. Like one is the audit logs of the pipeline that I was just mentioning right now. It's the same format of the PDF. PDF format is going to be the same. Here we'll capture the audit log is captured for each task added to the pipeline, right? So we navigated to our Azure DevOps platform. We open the releases section. We open the stage which was executed. We go to the logs page, which I was just showing right now on the DevOps part, where we open this particular page. Then we download that. We first record the time on which the execution was started, recorded inside the PDF. Then we'll download all the logs which are present on the pipeline. So let me just go back here a moment, and I'll be able to showcase what I actually mean. So if you see here, we can download the log file here, right? So all of that is embedded inside the single TPE report. So if I just click on this JSON file, it's not only PNG that we can support. JSON file will be embedded inside the TPE report, right? So if I just click on that, you'll be able to see all the logs embedded inside the PDF. So you don't have to go out of the PDF, to capture the logs and everything. Basically, you can have an evidence as a PNG report, a TXT file, or a JSON file, or any kind of textual document or XML file, whatever you want.
And if there's a failure, it says it's failed, and it captures why it failed, the logs, the errors, all that is captured, correct?
Exactly. So
and we open up a ticket in our service desk, correct? Like automatically a discrepancy report is opened.
Automatically it will be open. And the Jira bug key you'll be able to see inside this logs as well. So
okay. Shyam, I'm watching the clock also. So can we just move on to the next one also, which you wanted to show, right? You have one more small demo, right?
Yes. So now whatever we just saw in this particular PDF, there are some steps which are not covered in this particular PDF intentionally, only because we want to show it with our new platform, which is continuous intelligent validation. So I'll just go again show you this particular file, web action file, which was automatically generated by going through the Chrome browser and all of that. Given the time constraint, I'll just create a ticket on the platform and show you the generated PDF that is already present with us, which we ran a few minutes ago. So I'll just say SCADA.
Shyam, if you can just zoom in a little bit, please.
Yeah. We are good.
Yeah, again, the same information that we just inputted, the same file, click on send. Again, the ticket is created.
Shyam, there is no limitation as to it could be web-based, browser-based, it could be thick client, mobile, iPad, we can do anything, correct? The agents can log in as a regular user and operate on any platform, correct?
Yes, yes. And what you can see on my screen right now, whatever browser that I just pulled up, that is the execution has started already with our continuous agent, which is the AI-based agent that we have. In the meanwhile, let me just pull up this.
While Shyam is looking into that, Nagesh, there are two questions, right? How does automation enhance the SCADA validation process? If you can please answer that.
I mean, it enhances every aspect of SCADA validation. Like I walked you through in the first or second slide, the manual process is, very, very laborious. So with our intelligent validation, it's very easy to create a test script, to tell the bot what needs to be done. In plain English, you can do that, and that's all we need. And after that, our bot can run the entire test by intelligently understanding where to go, how to go, and generating the code that that drives the browser or any other app. It can do that, capture the evidence, And also, if it has to go enter a value, it can do it. If it has to assert a value, it can do it. If you want to acknowledge an alarm, it can do it. Any action a human can perform by seeing or by actually performing an action, the bot can perform. So that end-to-end is there. If you want to change the test case, it's very easy. You just go, it's like English, type it in whatever you want, and it automatically will do it. There's not much training needed. We have a mechanism for establishing a knowledge base, so that, the bots are familiar with, are trained on your platform. And after that, you just tell it what to do, and it can run the test end to end. It can really do everything a human does, and compile the report within minutes. All this will take maybe a few minutes, maybe half an hour, depending on the number of steps. So every aspect of the validation can be automated with more integrity, more speed, more cost efficiency, no doubt about that. And regression testing can be 100%. I don't believe in that risk-based regression testing because it's very subjective. So it's not scientific at all. So I really believe, when I started continuous validation 2016, that was one of the reasons I started continuous validation. Is, I don't believe in regression testing. We need to do 100% regression all the time. We can do that with automation. So humans don't have to do it because it takes too much time, but we can do it with automation. That answers
One
it.
associated question on that, Nagesh, right? By what percentage can automation reduce the time needed for SCADA validation?
It could be 90%, reduction. If you take the validation of the SCADA over, let's say, 3 years, or the life of the SCADA from initial validation through subsequent validations, I would say 80 to 90% can be reduced. And more testing, with more testing done for the same, you're not only reducing the cost, but you're giving a better quality product, more value added, because you can really stress test the SCADA and give a report that is trustworthy, because it's reliable, it's compliant, it's automated.
Right. And people can compare that easily, right? 80 to 90%, right?
Absolutely. I mean, we can prove that.
Yeah.
With LLMs, especially, I'm the confidence. You understand, right? Gitesh, is,
yeah.
Let's say 2 years ago, if you had asked me, maybe I would have said 50% cost efficiency. With LLMs, I'm very confident it's 90%.
True.
Because there's no code written by my engineers. The code is done by LLM on the fly.
Correct.
In the interest of the time, Nagesh, I'll just showcase the PDF that we generated. For
1 second, Shyam. There's one more question. Let's address the questions in the interest of time, and then we'll go through the PDF and the rest of the time. Yeah. What is the significance of providing a comprehensive system-generated audit trail, Nagesh? From GxP perspective,
the idea is that, the technology is there in today's technology. When we use our pipelines to run our test cases, it anyway provides a comprehensive system audit trail, because my engineers need to debug the system. So what we have done is, we take advantage of that, and we grab that and put it in a nice report without any human intervention. Let's say you run the test at 5:35, 5:36, that report is generated. So there is no somebody saying that you went and manipulated it or something. Nope. We grab it, we put it into that PDF, and that gives you all the log files, and we also give a nice summary of it. So it's more human readable. If you go to just raw log files, your head will start spinning, because it's way too long and it's very cryptic also. Unless you're a developer, you won't understand it. So we give you like a summary and embed the raw file also. So that's the significance of that audit trail.
Yeah. And that's what now Shyam is going to showcase the PDF, right, Shyam? If you can just showcase.
PDF is, he just did a simple test using web actions file. It's an English file, like a natural language file, and it ran the test. That's what he's going to show.
So So this is a part where we have utilized our CAV platform to do the test on SCADA, where we'll just navigate to the reports section, and we'll click on monthly operating report. And now, if you just see what kind of instruction I gave, is that total runtime of Chem1 pump, right? So it correctly captured the value.
Just zoom in, please. Zoom in, please.
Yes. So if you see, the Chem pump 1 value is 233.12, and let me just zoom. Yeah. So if you see here, it's 233.12 hours, and here also you can clearly see at 233.12 hours. It captured on the go. So every time we run this particular script, the values will automatically get updated in the PDF. So we don't have to worry about it. You can easily use this for monitoring as well. Next step is we actually highlight that, we need to verify if the time is less than the maintenance hours here. So if you see here, maintenance use is 400 hours and our time is 233, and we are clearly highlighting that for pump 1, right? So like, you can't miss anything from here, and it is clearly highlighted. And also, it's not only a very simple tabular information that we can pull in. I'll just showcase a very simple example where
Zoom in
I
again,
wanted to
please. Zoom in again, please.
yeah, I wanted to capture the value of the facility location. So if you see in the report is water district for some CA, right? And it correctly captured the value on the go. So I mean, you can give us any of the web pages or browser, we can do automation on that accurately. And just one more example, and after that I'll conclude. If you see here, I want to capture if the David Smith, who is responsible official for the validation or the compliance, if he has been contacted or not. I just said that if he has been contacted, we want to capture that value. So if you see, our engine correctly identified that he has been contacted. Yes, and you can see it clearly here that he has been contacted. So that is how granular we go with just very simple looking like file. So you can imagine how much.
And we have tools to generate this also, correct? We have our recorder generated,
Exactly.
right?
So we don't have to write it manually always.
Yeah. So I think we have developed we have eliminated the human intervention by 90%, I think. So over time, with reinforced learning, we'll make it better, where it can really write these on its own. You just give it some high level prompt, it can actually write that web actions file on its own. So that's where we are right now, and probably we'll get there with it this year. We will definitely get there this year.
Yep. Yeah.
We're sorry, we are about 3 minutes over, I think, maybe 5 minutes over. I really, really appreciate your time. And Shyam, thank you